During the JEE Main mock tests, my scores were showing a decreasing trend, and Anand Sir intervened in the right time and made corrections to my daily schedule, which helped me give my best performance on the day of my JEE Mains.
Hi guys, this is Sourav here and welcome to another session for electrochemistry. In this session, we would be talking about something known as galvanic cells. Hello to everybody जिन्होंने हमें last session में join किया था and everybody who is joining us for the very first time. The last session was just the introduction और आज हम अपने gears बदलेंगे. Today we would start this deep diving into the concepts. And today we would be discussing something known as galvanic cells. आज सेशन 2 लेक्चर 2 है. इसके आगे काफ़ी सारे लेक्चर्स होंगे इलेक्ट्रोकेमिस्ट्री को अच्छे से समझने के लिए, टू हैव अ वेरी गुड ग्रास्प ऑन द सब्जेक्ट. बट माई ओनली रिक्वेस्ट टू यू गाइज इज do as much as hard work as possible. Please do join us for every session. Also, please do join us on the Telegram group so as to interact with us directly. You can post your questions, you can interact with the other fellow members and interact with the teachers. And please do like, share and subscribe our videos and the channel because we are bringing a lot of amazing content for you guys. So hello to everybody. Hello Shiv, hello Adesh, hello Daraksha, hello Amandeep. So let's not waste any more time and let's start today's session. आज का सेशन बहुत इंटरेस्टिंग है, बहुत इजी सा भी है, बहुत सिंपल चीज़ों से हम स्टार्ट करेंगे. विल बिल्ड आवर फाउंडेशन एंड देन विल स्टार्ट सीमेंटिंग दैट विद डीप लाइक काफ़ी कंसेप्चुअल क्वेश्चंस को लेके हम उनको ज़्यादा सीमेंट करने की कोशिश करेंगे. ओके, सो लेट्स if your questions are non-academic in nature about books and anything else, please do reserve for them at the end of the session. I'll take up those questions at the end of the session. Okay, so चलिए आज का सेशन स्टार्ट करते हैं and please tell me a yes to everybody who is ready for today's session. Rahul, Shiv. So let's start today's session. आज का सेशन galvanic cells पे है. Now I have created a flow chart of what things would be discussed and what we would be discussing in future. So आप देख रहे हैं कि electrochemistry एक broad topic है in which we would be discussing galvanic cells and you can see that the color coding is like half of this it is blue. So इसका मतलब कि हम 50% of galvanic cells आज खत्म करेंगे and next class में we will discuss more about them. Okay. The galvanic cells part is divided into Nernst equation and characteristics. So Nernst equation is a very important topic. Nernst equation से बहुत ज़्यादा questions आते हैं. If you talk about the number of questions that come from electrochemistry, if there are 4 questions out of 30 in JEE Mains, 2 question Nernst equation से बिल्कुल रहेंगे. So Nernst equation, the problems, concentration cells, the characteristics of galvanic cells. Similarly, the second part of electrochemistry is electrolytic cells, which we will discuss in 2 parts: Faraday's laws and behavior of ions. Okay, Faraday's laws and behavior of ions. Behavior of ions में 2 part आ जाता है, one of which is very important, Colruy's law, conductance, and Faraday's law, electrolysis cases. जितने भी electrolysis cases हमारे पास possible हैं, we would be taking them. Now this is just a broad idea. For every topic we would have like every concept intensive topic. After the concept intensive topic gets over, I will schedule a quiz kind of a session in which we would want to make it as interactive as possible and advanced level quiz and mains level quiz, and after the whole topic gets over we will take a quiz session. Okay, so लेट्स स्टार्ट टुडेज सेशन. एंड आज का सेशन है गैल्वेनिक सेल्स पे. हम लोग देखते हैं चलिए गैल्वेनिक सेल्स होते क्या हैं एंड व्हाट इज द नीड फॉर गैल्वेनिक सेल्स. सो व्हाट इज अ गैल्वेनिक सेल? अ गैल्वेनिक सेल को वोल्टाइक सेल भी बोलते हैं. गैल्वेनिक सेल इज ऑल्सो नोन एज वोल्टाइक सेल. जो आप पेंसिल बैटरी यूज करते हो और द कार बैटरी जो यूज करते हो, दैट कम्स अंडर द कैटेगरी ऑफ गैल्वेनिक सेल. इट यूजेस द एनर्जी. ओके, it uses the energy which is released in a chemical reaction to generate electricity. Okay, I'm very fine. My name is not Saurav Ganguly. Okay, A galvanic cell uses the energy released during a chemical reaction to generate electricity. Now, in the previous session, we had learned that what kind of a chemical reaction we can utilize for generating electricity. If you could tell me कि which kind of a chemical reaction we take, कौन से chemical reaction हम लेते हैं, बहुत तरह के chemical reactions हैं, which type of a chemical reaction we take to generate electricity, could you please tell me in the comment section? Redox, very very good. We take redox reactions. We take redox reaction. Let's look at a redox reaction. We can see over here that there is a blue colored solution of copper sulfate in which zinc strip is dipped. Okay, blue colored solution of copper sulfate, zinc strip is dipped. After a while, what has happened is that zinc has converted into zinc sulfate, and you can see these black precipitate of copper depositing on the strip. Okay, so this is a redox reaction. This is a redox reaction. Since we know that this process takes place on its own, we can also call it spontaneous. Okay, so we can also call it spontaneous because the reaction takes place on its own. I do not have to do anything. कुछ मेहनत नहीं करनी पड़ रही है, कुछ काम नहीं करना पड़ रहा है. Reaction खुद से हो रहा है. This is a redox reaction, but is it generating electricity? Is it generating electricity? Let's look at that feature. So there are three important things. That I need to know in this case. First thing is it's a redox reaction. Okay, first thing is it's a redox reaction. That is very very obvious. It's a redox reaction. What happens during this process? There is something known as free energy. So free energy is not getting converted into electricity because we learned in the last class that we need a circuit. So free energy is not getting converted into electricity. What is it getting converted to? What is it getting converted to? किसमें convert हो रहा है? It is getting converted to heat energy. So ये जो solution है ना, ये solution, let's say you take a room temperature condition अगर 25 degree Celsius पे ये आपने एक solution लिया है and you put zinc strip into it, you will see that the solution heats up. Okay, the solution heats up. Why is the solution heating up? Because the free energy is getting converted to heat energy. Free energy बहुत सारी चीजों में convert हो सकता है. One of the forms of energy in which it can convert to is heat energy. Okay, it gets heat energy. Now what happens next? The electricity is not generated. Okay, electricity is not generated. So you have to remember that any chemical reaction will, even though it is a spontaneous and even though it is redox, will not generate electricity unless and until I have a design. Unless and until I have a design. तो वो design को क्या बोलते हैं? The design is known as the galvanic cell. So galvanic cell के बारे में सबसे पहले आइडिया दिया था Luigi Galvani, Italian scientist, Dr. Luigi Galvani. He was working on frogs. Okay, he was like, what he was trying to see is that if you provide electrical impulses, the frog's legs jerk, okay, or twitch. Okay, तो अगर आप electrical impulses provide करते हैं तो frog का leg jerk करता है. So he was of an idea that there is some connection. There is some connection with whatever chemical reaction is happening and the electrical energy which is involved. Now that idea was taken by a physicist named Alessandro Volta, and he developed the first cell in which we could convert chemical energy into electrical energy. Now what is required for converting chemical energy into electrical energy? So any other name for galvanic cell? Yes, it is also known by the name voltaic cell. Galvani के ऊपर galvanic cell आया है, and it is also known as voltaic cell. It has just taken up the same idea. So what are the basic things that we need to keep in mind so as to use the energy liberated in a chemical reaction for electrical energy? So first idea is to harness the free energy of chemical reaction. I need to split the reaction. Earlier what you had seen is that copper sulfate solution had a zinc strip. कॉपर सल्फेट सोल्यूशन हैज अ जिंक स्ट्रिप. सो अब मुझे करना क्या है, अब मेरे को वो रिएक्शन को स्प्लिट करना है. क्या रिएक्शन को स्प्लिट करना है? ऑक्सीडेशन रिएक्शन एंड रिडक्शन रिएक्शन. इफ दे टेक प्लेस विद इन द सेम कंटेनर, इट इज वेरी चैलेंजिंग टू हार्नेस दैट इलेक्ट्रिसिटी. हार्नेस का मतलब ऑब्टेन करना. ओके, जैसे आप हाइड्रो इलेक्ट्रिक पावर को ऑब्टेन करने के लिए यू बिल्ड अ डैम, सिमिलरली टू हार्नेस द energy or to utilize it to generate electrical energy, you need to split the reaction. आपको split करना पड़ेगा. split मतलब oxidation अलग जगह, reduction अलग जगह आपको करना पड़ेगा. okay, that's clear. इसके बाद का point क्या है? The next thing that we need to do is the two half reactions, one would be oxidation, the other one would be reduction. And what we need to do is the two half reactions are made to take place in different containers, and a wire is used. Unless and until wire is used, I cannot develop a galvanic cell. हम galvanic cell को नहीं. So पहला idea क्या? दो different container. One container will have oxidation reaction, the other container will have reduction reaction, and I need to connect a wire. Okay, I hope this is clear. So why is wire used? Because wire is the medium, it's the bridge through which electrons will travel. Okay, now current will not flow without wire. Very good, Anit. So let's learn how is the galvanic cell constructed. Construct कैसे करना है? What is the construction of it? So construction करने के लिए सबसे पहली चीज आपको क्या चाहिए? Okay, so I would not want you to prompt a lot of things in the chat box. पहली बात तो ये, आप एक कंटेनर लो. Okay, so let's look at what was the construction of the galvanic cell or the voltaic cell that Alessandro made. Okay, तो Alessandro ने क्या किया कि he took a container and एक बड़ा सा कंटेनर उसने ले लिया. इस बड़े कंटेनर के अंदर he put a membrane. So this is a membrane. Okay, this is a membrane. ये जो partition create किया गया है, you can see there is a partition. This partition is a membrane. ठीक है? Now on one side he took one type of solution. Okay, he took one type of solution. He took zinc sulfate solution. Okay, Rahul will get to that. Okay, Rahul will come to that. So he took zinc sulfate solution. दूसरे तरफ में उसने एक दूसरा solution लिया. He took copper sulfate solution and inserted a zinc electrode in one of the solution, inserted copper electrode in the copper sulfate solution. Now he connected both of these electrodes with wire and एक bulb से connect कर दिया, or you can connect it to an ammeter. So let's label this so that we can understand this completely. So this is our glass container. Okay, this is copper sulfate, this is copper. Okay, this is copper, this is zinc, this is zinc sulfate. Let's write it over here, copper sulfate, and this is a semi-permeable membrane. This is a semi-permeable membrane. We will learn the use of salt bridge. Don't worry about that. We'll come to that later. Okay, don't worry about that. एक तरीके से पढ़ने की कोशिश करते हैं. Okay, Same metal solution. Why? I'll explain that. So what is the, so this is a wire and this is a bulb. So many things you can see over here that have been taken. So this is copper. Now, what are the key features? What are the key features that we can observe from here? पहली बात तो ये कि you can see that a metal is dipped in a solution of its salt. So metal plus solution of its salt. The reason why this has been done is because it was observed that when a metal is being put in a solution of its salt, then there are two processes which can occur. दो प्रोसेस हो सकता है. Either metal thins out, या तो metal will become thin over a period of time. होता क्या है कि metal will become thin over a period of time, और strip thickens. दो चीजें हो सकती है. Okay, so when you take a metal electrode and put that thing in a solution of its salt, two things can happen. What are the two things that can happen? Let's say we take this. So two things ये हो सकते हैं, या तो either this can happen, either zinc can change into zinc 2 plus, either this can happen, or zinc 2 plus can change into zinc. There are two things which can happen. Either zinc can change into zinc 2 plus, or zinc 2 plus can change into zinc. Okay, there can be two things which can happen. Now we have to understand that whenever we are putting two such metal strips in their solutions and we are connecting to each other, one of these process will take place at one of the compartments, and यहाँ पे एक दूसरा एक opposite process चलेगा. Why it is so? क्योंकि आपका जो रिएक्शन हो रहा था वहां पे क्या हो रहा था, जिंक प्लस कॉपर सल्फेट इज चेंजिंग टू जिंक सल्फेट प्लस कॉपर. It means zinc is undergoing oxidation and copper is undergoing reduction. So in this part what will happen is zinc will change to zinc 2 plus. So metal slowly will come out in the solution, and what will happen, this electrode or this metal strip thins out. This metal electrode thins out. Okay, अब यहां पे अगर ये process हो रहा है, then what will be the process that will take place over here? Can you tell me? Okay, Joban Singh, let's reserve that question. What is the process that will take place over here? The process that will take place over here is Cu2 plus will change to Cu. So इसकी thickness आप increase होते हुए देखोगे. This will thicken. Okay, this will thicken. So slowly you will observe that the zinc electrode, इसको हम electrode बोल देते हैं, the zinc electrode will become thin and the copper electrode will become thick. Okay, zinc electrode will become thin and the copper electrode will become thick. इतना मुझे पता अभी चल चुका है. Okay, I have already understood this part. Let's try and understand what will happen at this electrode specifically. So what will happen at this one, at zinc electrode? So at zinc I will observe this process. Zinc changes to zinc 2 plus and gives out 2 electron. Okay, zinc will change into zinc 2 plus and this is oxidation. Now हमेशा याद रखो, remember wherever oxidation takes place, it is known as anode. Don't classify anode or cathode with polarity. Whenever oxidation takes place, where जिस इलेक्ट्रोड पे ऑक्सीडेशन होगा उसको हम एनोड बोलेंगे. तो ये इलेक्ट्रोड क्या हो जाएगा? एनोड. ओके, ये सॉल्यूशन क्या हो जाएगा? एनोड. और सॉरी, दिस इलेक्ट्रोड विल बी नोन एज एनोड. दिस इलेक्ट्रोड कॉपर, व्हाट विल दिस बिकम? Cathode. Okay, it will become cathode. So what will happen at copper? It will take up 2 electrons and become Cu. Clear? Now ये जो 2 electrons आपके निकले, these 2 electrons which came out, ये 2 electrons solution में नहीं जाते हैं. Okay, these 2 electrons will not go into the solution. What will happen? ये 2 इलेक्ट्रॉन इलेक्ट्रोड के ऊपर बैठे रहते हैं. These 2 electrons will keep sitting on the electrode. Okay, the 2 electrons that are given out, they will be sitting on the electrode. Since वो electrode के ऊपर बैठे हैं, the electrons if are sitting on the electrode, what will be the polarity of the electrode? The polarity of the electrode will be negative. The polarity of the electrode will be negative. So आप देख रहे हो कि ये जो एनोड है, ये एनोड हो जाता है नेगेटिव पोलैरिटी का. ओके, एनोड टर्न्स आउट टू हैव नेगेटिव पोलैरिटी. These electrons, अब ये इलेक्ट्रॉन ट्रैवल करेंगे. These electron, why it is negative polarity? अरे नेगेटिव इसलिए क्योंकि यहां पे इलेक्ट्रॉन्स बैठे हुए हैं. यहां से जो जिंक, ये सरफेस से जो जिंक यहां पे आया, जिंक 2+ बन के, तो इसके जो 2 इलेक्ट्रॉन्स हैं, these 2 electrons are now sitting on the surface of the electrode. Okay, these 2 electrons are sitting on the surface of the electrode, and because of that, क्योंकि इलेक्ट्रॉन्स के पास नेगेटिव चार्ज है, so this will carry a negative polarity. Okay, now these electrons will travel. अब ये इलेक्ट्रॉन भाई साहब ट्रैवल करेंगे. Okay, this is the direction of travel of electrons. Okay, now these electrons will travel and Cu2+ has to deposit on the surface of this. Cu2+, since is depositing on this surface, this electrode will carry positive polarity. This electrode will carry positive polarity. So can we say that anode is where oxidation occurs, which has negative polarity, and cathode reduction and positive polarity. Now remember, never ever try to identify cathode and anode on the basis of polarity. Never do that. Cathode and anode are classified on the basis of the reaction which happens. So reaction oxidation है, इसीलिए उसको anode बोलेंगे. Reduction है, इसीलिए cathode बोलते हैं. Okay? Now, this is clear. I hope this is clear. अब हमारे पास एक major problem आ जाता है. The problem is that this is positive, sorry, this is negative electrode, this is positive electrode. Electrons इस तरफ move कर रहे हैं. Okay? Electrons are moving in this direction, and slowly the in the medium zinc 2+ ion की concentration increase कर रही है, isn't it? Can we say that since the electrode is losing zinc 2+ ions, the concentration of zinc 2+ ion increase करता जा रहा है यहाँ पे solution में, isn't it? The concentration of zinc 2+ ion keeps on increasing in the solution. और यहां पे क्या हो रहा है? Cu2+ ion is deposited. So Cu2+ is getting removed from the solution. So whose concentration is increasing? Sulfate ion concentration is increasing. ओके, इसको एक बार फिर से समझते हैं. जिंक इलेक्ट्रोड से आयॉन्स मीडियम में आते हैं and in the medium zinc 2 plus ion concentration increases. Similarly over here Cu2 plus ion gets deposited, तो इनका concentration decrease करता आता है, और Cu2 plus जिन सल्फेट्स के साथ associated थे their concentration increases. So इनका concentration increase कर गया. Okay, now एक चीज देखते हैं. Whenever you are planning to construct a circuit, you want current to flow through the circuit, you have to complete the circuit. So इधर इलेक्ट्रॉन मूव कर रहे हैं, हमारा सर्किट कंप्लीट नहीं है. I need to complete the circuit. How would I complete the circuit? Now what will happen? These excess sulfate ion will move in this direction. The excess sulfate ion, यहां पे excess sulfate ion है और यहां पे combined zinc 2 plus ions हैं. So the excess sulfate ion will move in that direction. Okay, excess sulfate ion will move in that direction. Electrons का movement इस तरफ हो रहा है, ions का movement इस तरफ हो रहा है. Our circuit is complete. And now we would observe electricity. अब हमारा बल्ब ग्लो करेगा. Okay, now our bulb will glow. If this sulfate ion does not move, this will not happen. Now अगर हमने membrane को हटा दिया, if I remove the membrane, then what will happen is that there will be a mass mixing of these two solutions. हमारे पास तब oxidation half cell और reduction half cell जैसा नहीं रहेगा. Okay, why would the ions move? How ions will move? Ions can move, man, because of electrostatic force of attraction. There is zinc 2 plus, it will generate an electric field. The uncombined anion will move towards it. Okay, so first thing, I cannot remove. What was the purpose of this membrane? To separate the two solutions into two parts, to separate oxidation and reduction. Also the membrane prevents movement of zinc in this direction. It does not allow zinc to move in this direction. It only allows movement of sulfate ion. Okay, there is no role of membrane to complete the circuit. The role of membrane is to separate the solutions. What was the first criterion? I have to separate oxidation and reduction. Sir, why only sulfate? Because हमने solution sulfate का लिया है. अगर आप zinc nitrate लेते, if you would have taken zinc nitrate or copper nitrate, then also this reaction would have taken place. Okay, then also this would have taken place. So the anion's nature does not matter. Sulfates are easy to obtain. I just maintain a sense of equivalence और सिमिलैरिटी दोनों की तरफ हम मेंटेन कर देते हैं. अगर मैंने यहाँ पे जिंक नाइट्रेट लिया और यहाँ पे कॉपर सल्फेट ले लिया, still it will happen, still the current would flow, but what will happen is यहाँ पे मिक्सचर हो जाएगा. यहाँ पे जिंक नाइट्रेट भी प्रेजेंट रहेगा, कॉपर जिंक सल्फेट भी प्रेजेंट रहेगा. ओके, so how current flow with the membrane? Current is not flowing with the membrane. Current will always flow in this circuit, but I need to complete the circuit. Okay, I need to complete the circuit. So can you tell me the direction of current? Direction of current क्या होगी? In this direction. So current will flow from cathode to anode, and electrons flow from anode to cathode. Okay, sir, at the start of the reaction the membrane was not allowing movement of ions, but how does it, from the start of the reaction it allows movement of ion? But Shunya, tell me something. You would not, let's say आपके पास 100 rupees हैं, आपके ब्रदर के पास भी 100 rupees हैं, unless and until आपने कहीं पे उसको खर्च कर दिया, let's say you have spent your 100 rupees, let's say you have spent 10 rupees, only then you will ask for it. Okay, only then you will ask for it. आप वो deficiency जितनी की हुई है उसी के लिए आप लोगे. Okay, so there was an increase in zinc 2 plus, so sulfate moves. Earlier, there was equal concentration of zinc 2 plus ion, Cu2 plus ion, sulfate ion, no movement. But now, because there is an increase, sulfate will move. Okay? So, now this is the convention, this is the earlier design. The current design is something else. Current design जो जानते हो आप, वो आप जानते हो something with salt bridge. लेकिन salt bridge लाया क्यों गया? Why was salt bridge bought in the first place? So the current design is like this. In the current design, what we do is we take a chamber, we take another chamber. Now we do not take a membrane. We take this chamber. Amandeep, why zinc 2 plus does not move? Because it is selectively permeable. Selectively permeable allows some ions to move, others को move करने नहीं दे सकता है. Can zinc move? Yes, zinc could have moved had I used a permeable membrane, but I am using selectively permeable. It is allowing only sulfate ions to move. So I have taken two containers. ये containers में हमने क्या किया? दोनों solutions को separate कर दिया. I am no longer using membrane. I am no longer using membrane. So you can see that I have separated the two solutions. ये वाला zinc sulfate solution था. So this was zinc sulfate. This was zinc sulfate and this was copper sulfate. तो zinc sulfate को हमने separate कर दिया, copper sulfate को separate कर दिया. Okay. Now in zinc sulfate I dip zinc electrode. In copper sulfate I dip copper electrode. Okay. Now connect a wire, connect a bulb. But is the circuit complete? Is the circuit complete? Can you tell me if the circuit is complete? Can we allow sulfate ions to move from here to here? Can we do that? Is the circuit complete? No, the circuit is not complete. So to complete the circuit, I want ions to move. I want ions to move. What would be used to complete the circuit? I will use something known as this. ये आप लोग जो जानते हो, which is known as salt bridge. We will use a salt bridge to complete the circuit. Okay? I will use a salt bridge to complete the circuit. So let's label this. इसको label करते हैं. ये हो गया आपका zinc sulfate. This is zinc. This is copper. This is copper sulfate. Okay, this is our wire. Electrons will move in this direction. What is the polarity over here? Negative. What is the polarity over here? Positive. Okay, what is the polarity over here? Positive. And this is known as the salt bridge. This is known as the salt bridge. Now, what do we take salt bridge? What do we take in a salt bridge? In the salt bridge, we take potassium nitrate or NaNO3 or potassium chloride. Okay? We take potassium nitrate, NaNO3, potassium chloride. Why are these ions taken? So tell me something. If the reaction starts, zinc 2 plus ion concentration will increase. Zinc 2 plus ion concentration will increase over here. And if the reaction starts, sulfate ion concentration will increase over here. Isn't it? The zinc 2 plus ion concentration will increase in this part, sulfate ion concentration will increase in this part. So to neutralize the zinc 2 plus ion, increase in zinc 2 plus ion, from this solution nitrate ion will come or chloride ion will come. Okay, now this solution, sulfate cannot move. What will happen from this salt bridge? Nitrate ion will come so as to combine with the excess zinc 2 plus. And what will happen in this direction? Potassium ion will come so as to combine with excess sulfate ion. So you can see that the movement of ions is also taking place, movement of electrons is also occurring. The circuit is now complete, and now this can continue to provide electricity. Okay, this can continue to provide electricity. इसमें होता क्या है? The free energy of a chemical reaction is converted into something known as EMF. We will learn this while we would be discussing Nernst equation, but for now आप याद रखो कि ये दोनों constructions correct हैं. The two constructions, the previous construction and this construction, both of them are correct. However, there is a small drawback in the previous construction which we will learn while we would be discussing Nernst equation. वो उस पे हम फिर से आएंगे. Okay, so I'm again explaining what happens in the salt bridge. We take a salt bridge which is filled with either potassium nitrate, NaNO3 or KCl. But you will see that as the reaction starts, zinc 2 plus ion concentration will increase. So nitrate ion will come, or chloride ion will come, to combine with this, to neutralize this. What you will see over here is potassium ion will come to combine with sulfate ion. Why? जिंक आयंस कैसे मूव करेंगे यार? जिंक आयंस इधर से इधर नहीं मूव करते हैं. ओके, दे कांट मूव, दे डोंट मूव इन द बैकवर्ड डायरेक्शन. Salt bridge is taken just to ensure that the circuit is complete and the electrical neutrality is maintained. Okay, so नहीं तो क्या होगा कि जो solution होगा, this solution will become positively charged, and this solution will become negatively charged. Okay. How salt bridge maintain liquid potential in both containers, we'll get to that later, Anand. Okay, so this is the basic construct of a galvanic cell. Now, what are the other informations that we can derive using a galvanic cell? क्या क्या information निकाल सकते हैं? So ये information निकालना अगर आपको आ गया, then half of the topic of galvanic cell is understood. So what are the things that we can learn? We can learn about what is the oxidation half cell. कितनी चीजें हम निकाल सकते हैं? Can you tell me how many information can we obtain? We can obtain almost 10 or 11 information. Okay, 10 or 11. I will take only 8 informations today because कुछ चीजें हम लोग Nernst equation के बाद सीखेंगे. Okay, so we can understand 8 such things. Okay, so what was the oxidation half cell? Oxidation half cell, or OHC, is where oxidation takes place. Oxidation takes place. Okay, oxidation takes place. इसको हम लिखेंगे इस तरह से, zinc changes to zinc 2 plus gives out 2 electron. Zinc changes to zinc 2 plus gives out 2 electrons. Now what was the state in which zinc electrode was taken? Was it a solid state or liquid state or gaseous state? क्या state था वो? It was solid. And zinc 2 plus ions are taken in the aqueous state because zinc 2 plus ions are present in the solution form. So यहाँ पे हम लिख देंगे aqueous. Okay, so this is our oxidation half cell. What will be the reduction half cell? Reduction half cell will be written as RHC. This is where reduction takes place, and this will be written as Cu2 plus takes up 2 electron, changes to Cu. Do not forget to write the state in which they are present. So this is present in aqueous and this is present in solid state. Okay, this is present in solid state, this is present in aqueous. What is the cell reaction? Okay, what is the cell reaction? Cell reaction is the overall reaction. Overall reaction. So you will add both of them, cancel out the electrons and write the overall reaction. You will write it as zinc solid plus Cu2 plus aqueous changes to Cu solid plus zinc 2 plus aqueous. The sum of oxidation half cell reaction and reduction half cell reaction is the cell reaction. Okay. Next is cell representation. Now cell representation is very important. इसके ऊपर JEE में बहुत बार क्वेश्चन पूछा गया है. On any other examination also this representation is quite important. How do you represent this? So remember, I will always represent the anode on the left and the cathode on the right. So always I will represent anode on the left, separate it with two vertical lines, and cathode on the right. Okay, anode on the left and cathode on the right. शिव इलेक्ट्रॉन्स तो कैंसिल हो जाते हैं ना, ये इलेक्ट्रॉन्स तो कैंसिल हो जाएंगे, साइमल्टेनियस इक्वेशन जैसे कैंसिल हो गए. एनोड ऑन द लेफ्ट एंड कैथोड ऑन द राइट. दिस इज अ कन्वेंशन, नॉट अ वाई. कन्वेंशन है ये. ओके, लिखने का तरीका, जैसे कि इंडिया में कार चलाने की when you drive your vehicle or when you walk, you're supposed to walk on the left side of the road because the vehicles आप right-handed drive आप करते हो. Okay, left-handed driving नहीं है. So it's just a convention. So anode on the left and cathode on the right. Now anode में कौन सा reaction हो रहा है? Zinc solid which is converting into zinc 2 plus aqueous. ठीक है? Is there a phase boundary? Is there a phase boundary? Phase boundary means is the state of this electrode and the ion which is produced different? Yes, this is solid, this is like aqueous. So इनके बीच में एक vertical line रखेंगे. I'll put a single vertical line. If the state is alike, I'll put a comma. Okay, many a times we'll see some more complicated cases in the next class. This is solid, this is aqueous, state is different, so I'll put a single vertical line. Two vertical lines, the two vertical lines represent salt bridge. Okay, और यहाँ पे क्या लिखेंगे? What is happening over here? Cu2 plus aqueous is changing into Cu solid. Okay, Cu2 plus aqueous will change to Cu solid. What is the anode? Zinc is anode. What is the polarity of anode? Negative. What is the cathode? Copper. What is the polarity of cathode? Positive. Okay. Now, if you would be asked कि यहाँ पे कुछ concentration दिया गया, let's say 1 molar concentration of zinc sulfate, then you will write in brackets whatever is the concentration. If concentration is given, you will write it in the brackets, but unless concentration is not known, we do not need to put concentration over here. Okay. Direction of electrons. What was the direction of electrons? Can you tell me what was the direction of electron from zinc to copper? What was the direction of current from copper to zinc? ठीक है? Not, don't ever say left to right. You can always say anode to cathode, and over here cathode to anode. ठीक है? So बस इतना हमारे लिए enough है. Okay, this takes up a certain amount of importance while studying galvanic cells. There are some other things that we also need to know. What is the EMF which is generated? Because over here free energy is converting into the EMF. Okay, what is the EMF which is generated? What is the cell potential? Cell potential. What is the standard electrode potential? इन चीज़ों के बारे में हम जो पढ़ाई करेंगे, this we will discuss in the next session, which will be on Nernst equation. So in this session we have just covered how to draw a galvanic cell, what are the various parts of galvanic cell, कहाँ oxidation होता है, कहाँ reduction होता है, why salt bridge is used, what are the different informations that we can use, and which is anode, which is cathode, electron किधर move करते हैं, current किधर move करता है. ओके, न्यूमेरिकल्स कब करेंगे? न्यूमेरिकल्स बाद में करेंगे जब थ्योरी खत्म हो जाएगी, पहले थ्योरी समझ लो अपने से। ओके, फर्स्ट बी वेरी वेरी थॉरो विद द थ्योरी। आजकल एग्जामिनेशन में जो क्वेश्चंस आ रहे हैं विच आर नॉट वेरी कैलकुलेशन इंटेंसिव, कंसेप्चुअल अंडरस्टैंडिंग इज इंपॉर्टेंट, ठीक है? सो दिस इज द लास्ट थिंग फॉर टुडे, एंड the next class would be of Pulkit sir. Please do stay for that, and 8 p.m. also he'll be taking functions and graphs, so please stay for that. I will join you guys on Friday and we'll discuss the rest of part of galvanic cells, ठीक है? So please do join us on that day as well. थोड़ा सा पढ़ाई करके आइए, अच्छा रहता है, previous sessions देख के आइए, and please do like, share and subscribe our channel and the videos. That's all that I can ask you guys. Okay? Sir, English का use थोड़ा कम बोलो please. I will try to mix both of them. Okay? चलिए. Have a lovely day ahead guys. Bye bye.